Why is the periodic table arranged as it is? Have you ever wondered why the periodic table looks the way it does? The arrangement of the periodic table is a fascinating story that reflects the patterns in the properties of elements. This organization helps scientists understand how different elements behave and interact with one another. The periodic table is arranged based on the atomic number, which is the number of protons in an atom's nucleus. This method replaced the earlier system of organizing elements by atomic weight. The switch to atomic number resolved many inconsistencies and allowed for a clearer understanding of element properties. The journey of the periodic table began with Dmitri Mendeleev in 1869. He was the first to create a table that grouped elements with similar chemical properties into columns. Mendeleev noticed that when elements were arranged by increasing atomic weight, certain properties repeated at regular intervals. This observation led to the formulation of the law of periodicity. Mendeleev's table was remarkable because he left gaps for elements that had not yet been discovered. He predicted their properties based on the patterns he observed. This ability to foresee the existence and characteristics of unknown elements was a major step forward in chemistry. Before Mendeleev, other scientists like Julius Lothar Meyer and Alexandre-Émile Baguier de Chancourtois attempted to classify elements. However, their methods did not capture the periodic nature of element properties as effectively as Mendeleev's table. In the modern periodic table, elements are organized into rows called periods and columns known as groups. As you move across a period, the number of protons and electrons increases, which alters the properties of the elements. When you move down a group, the elements share similar outer electron arrangements, leading to similar chemical behaviors. This arrangement is essential for understanding the relationships between elements. It allows scientists to predict how elements will react with one another, which is vital for discovering new compounds and materials. The periodic table has become a key milestone in science, representing a major innovation that organizes chemical knowledge into a coherent system. It continues to guide research and education today, helping us understand the principles of matter and energy. So next time you look at the periodic table, remember that its arrangement is not just a random collection of elements, but a carefully structured reflection of the nature of matter itself.